Okay, so here is lesson 5, and it's going to be with integration with substitution with limits. But first, here is our starter question. It's from the 2018 question 1B. It's only worth 2 marks. So pause the video, try this by yourself. Okay, here comes the answers. It's only worth 2 marks. Give yourself a mark out of 2. Okay, now can you take your notes jotter? We're taking a new heading today. Okay, so your heading is going to be definite integrals with substitution. Okay, so a definite integral, just as a fancy way of saying it's an integral with limits. That's the only difference. Okay, and there is only one question that I'm going to go through with you today. So question 1. So let's integrate between the limits of 0 and 1. 15x squared, open bracket, x cubed plus 1, close bracket, to the power of 4 dx, given that u is equal to x cubed plus 1. Okay, so that's your question. Okay, so the first part of your answer is basically the exact same as what we've been doing over the past 2 days with lesson 3 and 4. Okay, look at our substitution. Is there anything that we can swap out? Yes, there is, because it's the exact same as what's inside this bracket. So I'm just going to keep everything else the same. Between the limits of 0 and 1, 15x squared, that bracket can just change for u to the power of 4 dx. Okay, so nothing's different from what we've done before. We're going to do the same thing. We're going to differentiate this. So I'm differentiating u, and it's with respect to x. So du over dx. If you differentiate this, that gives you 3x squared. Now remember, I'm looking to swap out dx. So I'm trying to get dx by itself. So multiply both sides by dx. And then what you're going to do is you're going to divide by the 3x squared, and that will give you dx by itself, which is what you want. Good. Now what we can do is we can swap out dx, because we know what that is. Okay, everything else stays the same. Okay, so dx is now going to be du over 3x squared. Okay, so that's actually worked out quite nice for us, because I've got an x squared up here and I've got an x squared down there, so they cancel off with each other. You've also got a 15 over 3, so 15 divided by 3 gives you 5 u to the power of 4 du. Right, now let's deal with these limits. So at the minute these limits are in terms of x, but you know how we've changed all of our x's for u? I also need to do the same for the limits. So I want my limits in terms of u in this case. So I'm just going to go back to this right hand side, and we're just going to do our working. So it's really important that you change your limits, otherwise you'll end up with a completely different answer. Okay, so I'm just going to write in here new limits. Put in capitals so you don't forget to do it. Okay, let's deal with the lower limit first. So 0. So right now this is x equals 0, because it's an x limit. So if I go back up to the substitution that's given to me, so what I'm going to be looking at, I'll highlight it up here so you can see it, is this part I'm going to be looking at. Okay, so if I know that x is 0, if you swap x is 0 into that, what you're going to get is u equals 0 plus 1, 0 cubed plus 1, which is just going to be 1. Okay, so that means that your lower limit is just going to be 1 in this case. Let's look at your upper limit. So this is when x equals 1. What you're doing, you're changing x for a 1, and let's see what u is equal to. So we're going to have 1 cubed plus 1, which is obviously 2. So your upper limit is going to be 2. Everything else can stay the same. Now, see if that happened, that the lower limit was actually bigger than the upper limit. This happened in lesson 2 or lesson 3 in one of the questions, I think. The number at the bottom needs to be the smaller number, but if that's not the case when you work out your new limits, all you can do is you can swap them around, but just put a negative sign at the front. Okay, so that might happen, it doesn't in this case. So we're actually ready for integration now. So basic integral, we increase the power, divide by the new power. There's nothing complicated about this. 2 and 1. We don't need to swap u back out for whatever it was. I'm just going to cancel that, so that's just going to become u to the power of 5, because the 5 and 5 cancel. Okay, so if you sub in your limits, it's just going to give you 2. Oops, what was it? So we're changing u for 2, so it's just going to be 2 to the power of 5, take away, and then change u for 1. Just like this. Okay, so this could come up in a non-calculator paper. 2 to the power of 5 is just going to give you 32. 1 to the power of 5 is just 1. So your final answer is going to be 31. Okay, that's the only question that I'm going through with you today. The questions that I've got for you are question 38 to 45, and as always, please ask if you're stuck at anything.